Hi, algebra students. Today we're going to take a look at this section on multiplying polynomials. So this is something that won't be entirely new to you, but it is going to incorporate the idea of adding, subtracting, and multiplying polynomials. And it is our geometry application, so it's important to what you're going to see next year in geometry. So let's take a look at this first example. It says you have a purple piece of stained glass, and it has a trapezoidal shape. So the directions say, write a polynomial that represents the area of the piece of glass. So the first thing we're going to have to do is find our area formula for a trapezoid. So if you don't know that, of course, you have lots of resources. You could look it up, but I'm going to go ahead and give it to you so we can get started. So for the area of the trapezoid, it's 1/2 times the sum of the two bases. So we say base sub 1 plus base sub 2 times the height. So if you take a look at our figure here, the bases are the two sides that are parallel. So one base measures a length of x and one base measures a length of 3x minus 6. And then the height is always measured at a 90-degree angle, and that's this algebraic expression here, the x minus 1 inches. So I'm just going to substitute all of that into our formula. So it's 1/2. And then in parentheses, we have the 3x minus 6 plus x, and then times our height, which is x minus 1. Okay, so remember when you're utilizing these formulas that it's important to think about order of operations. So I want to simplify everything inside of the parentheses here first. So I'm just going to combine my like terms. So I have area equals 1/2, and then 3x plus x is 4x minus 6. And then we have the x minus 1. Okay, so there's a couple of different ways that you can go about this. You can either FOIL this first, because of course we have a binomial times a binomial, so you can FOIL that first, and then remember multiplying by half is the same as dividing by 2. Or you have the option of distributing the 1/2 first, which might make this a little bit simpler, so I think I'm going to choose to go that route. So if you distribute the 1/2, so 1/2 of 4 is 2x, and 1/2 of 6 is 3. So notice that 1/2 just gets distributed to the first set of parentheses, not the second. And then we're left with two binomials, so now we're going to go ahead and FOIL this. So let's see, the product of my first 2x times x is 2x squared. The product of my outers is negative 2x. The product of my inners is negative 3x. And the product of my two terms that are last, a negative times a negative, is a positive 3. So my final step is just to clean this all up. So I just want to combine these like terms in the middle. So I have 2x squared minus 5x plus 3. Okay, so notice that's our polynomial that represents the area of the piece of glass. And I, unless I had additional information, I can't do anything with that right now. But notice in question B or part B, it says find the area of the piece of glass when the shorter base is x. And the shorter base is 7 inches. The shorter base is labeled x. So that means when x equals 7, what is the area of the stained glass? So we're going to take 7 and we're going to substitute it in place of x here and here. So we're just evaluating this polynomial when x is 7. So 2 times 7 squared minus 5 times 7 plus 3. Now, of course, you have a graphing calculator. You could plug this all in, or just a little bit of mental math is easy enough also. So just remember order of operations. Say you have to do exponents first. So it's 2 times 49. 5 times 7 is 35. So all of our multiplications before we add. And then 2 times 49 is 98 minus 35 plus 3. And then don't forget you have to follow your left to right rule here. Okay, so I'm going to pause for a minute and grab my calculator. Okay, so I just wanted to double check on my computation, but I believe the answer is 66. And on this one we do have a label. So we need to make sure we label our answer. All of our dimensions are labeled in inches, and remember, area is measured in square units. So our final answer would be 66 square inches. So that's the answer to part B. All right, let's go ahead and move on. So this next set of polynomials says, find a polynomial that represents the area of the shaded region. So again, first you want to look at the shape, what kind of shape it is. So this one's a rectangle. So always start with your formula. So in this case, area is equal to the length times the width. So we have 2x minus 9. And remember, you're multiplying that by the entire length of the entire side. So you do need parentheses there. And again, we're going to FOIL these. So let's see. Product of our first is 2x squared. Product of our outers is 10x, positive 10x. Product of my inside is negative 9x. And the product of my two last terms, negative 9 times 5 is negative 45. Okay, so we're just going to clean up all of these terms and add them together. So area is 2x squared. And then we have minus x minus 45. And you can, I mean, that's essentially what goes on this line up here if you want. But I'm just going to leave it right there. I am going to remind you that in your assignment tonight, you have several questions on the front that deal with perimeter. So just remember, if we were doing perimeter for this shape is 2 times the length plus 2 times the width. Or, you know, so you're just doing 2 times x plus 5 and 2 times 2x minus, whoops, that's a 9. So 2x minus 9. So you would distribute here, and then combine all of your like terms. Or, of course, you can just add up all those sides. All right, let's take a look at our next shape. This is a triangle. Remember, triangles have a different area formula. It's 1/2 times the base times the height. Or, of course, you can write base times height divided by 2. So let's show what we know. We know the measure or the dimension of the base is p plus 1. The dimension of our height is 2p minus 6. Okay, so kind of like I talked about up here, when you have a fraction there, you can distribute that first. It doesn't look like it's going to help us here, or you can FOIL it and then multiply by 1/2, which I think I'll do on this one just to show you the difference. So if I do my product of my first, that gives me 2p squared. Product of my outers is negative 6p. The product of my inners is 2p, and the product of my last is negative 6. Now, when you, well, let's go ahead and simplify this and combine our like terms, and then I'll distribute that 1/2 in a moment. I'm going to move up here so I can have a little bit more space. So 1/2 times 2p squared, and then that would be minus 4p minus 6. So when we distribute this 1/2, I'll go ahead and put my final answer on the line for this one. 1/2 of 2 is 1, so it's p squared. 1/2 of 4 is 2, so 2p, and 1/2 of 6 is 3. So this right here would be my final answer. Okay, so those are pretty simple geometry applications in terms of utilizing your area formulas. Now we're going to look at some area of a shaded region, and we talked about these the other day, and I reminded you of this formula and how I would write it. So if you're finding the area of the shaded region, remember I said it's the area of the big shape. Okay, this one says the full figure. That's your big shape, and the area of the non-shaded region, that's your small shape. Okay, so for example, here we have a square, and the formula for the area of a square is just side squared. And then we have a rectangle. Our formula for the rectangle is length times width. So we want to do the area of the big square. So x plus 1 times x plus 1. And then eventually we're going to subtract the area of the little rectangle on the inside. So length times width would be 5 times x minus 7. And again, just think about order of operations here. So we have to start by FOILing this polynomial at the front. So x times x is x squared. The product of my outers is 1x. The product of my inners is also 1x. And the product of my two last terms, 1 times 1 is just 1. When you distribute on this side, remember that 5 has a subtraction sign in front of it, so you're distributing a negative 5 to everything inside the parentheses. So negative 5 times x is negative 5x. Negative 5 times negative 7 is positive 35. Now we can go ahead and clean this up by combining all of our like terms. So I'm going to write my final answer as area equals, I don't have anything to combine with that x squared, but I have a positive 1x, and a negative 5x that I can combine. So let's see, negative 5 plus 2 is negative 3x. And then I have a positive 35 and a positive 1, so that gives me a 36. So x squared minus 3x plus 36 is the expression that represents the area of the shaded region. All right, let's take a look at this final problem. So this one is a square on the outside, and then we have this triangle on the inside. Okay, so the area of our square is length, and actually I stand corrected, it is not a square, it is a rectangle, because those dimensions are not exactly the same. So just length times width, and then as we discussed above, 1/2 times the base times the height for the triangle. So let's start with the dimensions of our square. Sorry, let me clean this up real quick. Okay, x plus 6 times x plus 5. So that's the area of our square. And then we're going to subtract from that the area of the triangle. So 1/2, I don't know why I wrote that twice, times the base, which is x plus 6, times the height, which is x plus 5. I'm running out of room here. We'll have to squeeze that in. Sorry about that. Okay, FOIL, distribute. Okay, so x plus 6 times x plus 5 is x squared plus 6x plus 5x plus 30. If you notice, we're actually foiling the exact same polynomial over here, so because I'm out of room and I wrote this kind of sloppy, I'm going to simplify this side, and then we'll just clean it all up. So we have x squared, and then 6 and 5 is 11x plus 30. And then we're going to subtract half of x squared plus 11x plus 30. All right, bringing this down here. I'm sorry, this is not very neat. So let's clean this up. I'm just going to drop all of this down. So x squared plus 11x plus 30. And then I have to distribute the half here, which gets kind of messy. So it's minus 1/2 x squared. And then 11 does not divide evenly by 2, so I'm just going to write that as negative 11/2 x. And then half of 30 is 15, but I'm distributing the negative, so it's minus 15. All right, so let's clean all this up. X squared minus 1/2 x squared is just 1/2 x squared. 11x minus 11/2 is 11/2 x. And then 30 take away 15 is negative 15. If I am not mistaken, I think you had this exact problem in your homework the other night, so it should look pretty familiar to you. All right, team, so you have some application problems. They're not going to all be exactly like this, but do your best, read the directions carefully, and make sure you show your work.